Well, thank you everyone for joining us today for the latest in the Sockeye webinar series, Thinking Inside the Box. Our guest speaker today is Jeff Shiver of People Processes, Inc. Jeff's been leading people and enterprises to overcome the reliability and operational challenges for over 25 years. He's a published author, a speaker, and a trusted advisor to the maintenance and reliability community around the globe. Jeff also serves the CMRP as the Membership Services Director, and it's a pleasure to have him on board today. Ever so briefly, my name is Charles Hamer, CEO of Sockeye Technologies. Sockeye distills best practices for maintenance scheduling into a simple tool that works with any CMMS. Just before we get underway, you'll notice on the right-hand side, there's a chat box. You can register questions there. We'll do our best to answer them as we go through the webinar. And we'll also be asking a few questions as we go through. We'll be polling for responses. So thanks very much, everyone. And Jeff, I'll turn it over to you.
Thank you so much, Charles, and thank you for having me on the webinar. Hello, everyone. Great to have you here with us. And I'm looking forward to actually delivering some of my experiences and insights on the webinar. I want to point out a couple things here. Charles mentioned my background and that type thing, but I want to call to your attention the Plant Services, the Ask Jeff blog at plantservices.com. Also the maintenance and reliability for managers, which actually is a podcast that will be coming out in a couple of weeks for that. And it'll actually be at maintenance and reliability for managers.com. And of course, you can get it on iTunes, Stitcher, and all the other places that you pull your podcast from. Also, I have some additional upcoming conferences where you can meet with me in person if you like. And we have the CBM conference that's a couple weeks out. The Reliable Plant, the Marcon conference, and the symposium all are next year, the start of next year. And you see my email address there as well. Please do send me a note or whatever if I can help you in any way. So moving on actually into the content. So Charles, we're going to start off with a poll question, but before we do that, I want to share some insights with regard to what I'm looking for with the question. And really the question is, you know, if we think about reliability, asset reliability, what tool could we choose? If we could only pick one tool, what would you pick that would actually drive asset reliability? So Charles, if you'll launch that poll for us.
There we go. It should be visible. There we go. Just waiting for results here, Jeff.
Okay, give me just a couple more seconds, and then we'll.
Okay. So nobody said hammer, unfortunately. Roughly half were planning. 30% were standardized work.
Okay, you need to. Did you close the poll by chance?
I'll close it now. Yep.
Okay. All right, and what were your results again?
There we are. Can everybody see that, Jeff?
I'm not seeing it, but it's okay.
Oh, I'll just read it out. So 42% said planning, 8% said scheduling, 25 standardized work, and 25 operator training.
Okay. Well, let's talk about that a little bit. So I'm going to borrow something from Winston LeDay, and he leveraged this in his book, Just Don't Fix It, Improve It. But what he talks about is the reality for most organizations is they're reactive. And I'll add some pieces to that, some statistics. What we find from studies is roughly about 60% of all organizations are reactive. So if you go in and you look, for example, at your planned versus unplanned ratio of the work you actually do, you know, if you're doing much more unplanned work than planned, then probably you're reactive. You know, and some of you may be doing as much as 80 or 90% reactive work. So as part of that, when we look at it, many organizations are trying to simply get to the planned domain. We think about these in terms of domains, reactive domains, planned domains, and even consulting groups try to get you in the planned domain. Reality is though it's not actually about planning and scheduling more work. Somewhat counterintuitive, but the reality is we have to go after the precision domain. And when we look at the precision domain, what we're looking for are things like corrective job plans, PM task lists. How do we actually eliminate and drive? How do we eliminate defects, but also how do we drive the time between failures, the MTBF, the mean time between failures? How do we drive that time out? For example, if you have pumps, and if you think about centrifugal pumps as a class, if you have those and you're getting, say, 60 months on average, how do you get to 84 months? How do you get to 100 months? So those are kind of things we're looking at from a defect elimination standpoint. Also, even when you do your corrective job plans, how do you assign precision tasks? So in other words, it's not just about, fixing the pump, but how do you set the gap, the torque, the clearances, all those type of things to specific values. We talk about root cause analysis. Root cause analysis, for every work order you get in the system, there may be as many as 10 actual failure modes that could be addressed as part of that, or 10 root causes, I should say. And so when you go looking, lots of opportunities to drive toward the precision domain. Same thing with regard to operator-driven reliability. As part of basic care, operators doing basic PMs, and operations procedures, or SOPs. And it happens that Bob Williamson some years ago wrote an article, and he talked about the #1 tool for reliability, and he agrees that it's standardized work. So how do we get everybody on the same page doing the same thing? And the challenge for us is this: we're not trying to kill the creativity of the crafts. We want to leverage the craft skills, but we have to do it to a standard. And that way we can ensure everybody does it the same way. When things go wrong, we can go back and fix it. For example, if you have somebody who's doing something one way and another person's doing it another way and another person's doing it yet a third way, the problem is when you have a failure, which way actually caused the failure? So when we think about it, we have to get everybody standardized. Now, talking about systems thinking, in maintenance, we often don't think in terms of business or finance, but if I share with you, most entrepreneurs think all the time about how do they grow the business? How do they scale it once they get it to a certain size and take it to the next level? Maybe they're trying to take it from 5 figures to 6 figures, 6 figures to 7, at some point 7 to 8 figures. And with them, they're applying concepts around business processes and other things. So if we look at maintenance and we turn this back around toward maintenance, let's look at what's happening. Many of you suffer retirements. Lots of people, the baby boomers are retiring. By the year 2025, we'll basically take out 80 million people out of the workforce and only replace them with about 40 million. And of those, only about 20% have any knowledge-based skills. And then people are shifting positions. We're at 4% unemployment in the United States, as an example. And based on that, people are rotating jobs or moving into different positions. Maybe it's different companies. And business priorities shift as well. We're moving into more augmented reality and IoT and other type things like that. So the real challenge for us within the maintenance world is how do we think about scaling? How do we think about training new people as they come in? So one of the things we have to really do is define our processes. And I ask this question for you. If you think about your business processes, for example, do you actually plan work? How do you do work identification? How do you put work orders into the system? How do you approve those? How do you interface with the stockroom? And so these are all components from a business process standpoint. And at the end of the day, we really need graphical workflows that represent those. And when you put in tools like, Sockeye and the scheduling tools, you actually have those processes. You define those processes, and then talk about roles and responsibilities. And when you define your processes, you have an opportunity to create what's called RACIs. And it's short for responsibility, accountability, consult or support, and information. RACI. C-R-S, and then I, RASI. So I'll share with you why they're so important. And I was recently at a site, and what I saw was I went to the planner schedulers, and the planner schedulers were actually ordering parts, and they would call the vendor, they would identify the parts, call the vendor, get quotes from the vendor, and then they would, go through all these exercises selecting it, and then they would turn it over to the commercial or the purchasing people in the storeroom. And interestingly enough, I went and talked to the person in the storeroom. And that individual said, well, I have these handshake agreements with the vendors. And so basically, while the planner scheduler can go and determine who they want to buy from, I'm going to buy it from who I want to buy from. And oftentimes it's not the same person. And so you see this duplication of effort. And that's what we get into, is we have to make sure that we've clearly defined roles and responsibilities, and we're all staying within the lanes, if you will, to make sure that we're not duplicating efforts. And then even in terms of things like detailed job plans, that's part of a process. And it's job plans become training tools. And while we talk about we still have to leverage the skills of the crafts, when we talk about retirements and new people coming on, how do we actually leverage that? And then we also have a feedback loop. And you really need the feedback loop that's coming back from when the technicians execute the planning and scheduling, when they execute the work, then it comes back to planning. And the planners actually have an opportunity to improve the job plan, or improve the PM, or improve other processes. So these are really things that you have to be considering as part of systems thinking. And we're going to actually talk a little bit more in a minute about systems thinking continuing on. But first, I want to show you basically a big picture flow chart. And this is somewhat generic, but you see that we start off with some level of analysis, be it reliability centered maintenance, be it failure modes and effects analysis, or be it simple PM optimization or PM development. And then what happens is, especially with RCM, what we're trying to do is develop maintenance strategies. And we come out with proactive maintenance task procedures. We put those into the computerized maintenance management system. We workload level and trigger those, and then we put out a schedule. And as part of that, we then coordinate the work we executed. And here's that feedback loop I was talking about coming back into planning. We build corrective job plans. If we have to have materials, we source those from the stockroom or some other third party. And then it just continuously loops. But now I want to focus back in specifically on the systems thinking component. And with regard to systems thinking, I think it's probably important that we spend a minute to talk about what systems thinking is. And the reality is that everybody is pretty much part of a system. So if we think about, for example, like a football team, there are a whole lot of interdependencies. You've got the guards, and you've got the tackles, and you've got the tight end, and you've got the receivers, and all those type people, and everybody has a function. But they all have to work together to move the ball down the field, or in some cases defend against the ball being moved down the field for them. And without those interdependencies, we just have a collection of parts. And I want to point that out something to you. If we look, for example, at just the work execution piece, we talked about in this webinar that we talked about thinking inside the box, but here you actually have to think outside the box. And what do I mean by that? Well, if we look at the interdependencies, for example, like planning, supervisors get involved in planning, technicians get involved in planning. And when we talk about corrective job plans, same thing. The technicians are actually the ones who provide input into those, provide feedback on the backside. But in addition to that, I want to add one piece. It's a mistake to think that a planner scheduler is going to give a perfect job plan every time to the technician. The purpose of planning is to give the technicians a head start. Task steps, materials, any kind of safety considerations, that type thing. But what we have to do is we have to basically balance that, because what I mean by that is we still want to leverage the skills of the craft. If we look at materials, for example, we have the storeroom. A lot of interdependencies with the storeroom, and also with procurement, who may actually in many cases own the storeroom functionality. We've got production scheduling that impacts the maintenance schedule. We might leverage contractors that impact our ability to coordinate the actual work. And of course, the production workers having access to the equipment to be able to do it, the work itself. So when we talk about boots on the ground, spend a little time here with regard to the planner scheduler position. And I often see planner schedulers put into the position without craft skills. It's not that it cannot be learned, it can. The learning curve is steeper. Ideally, the best person to plan the work is somebody who's done the work in the past. So if in many companies, what we actually say is that it's better if the planner or scheduler actually is one of your best craftspeople. And sometimes that gives heartburn to the organization. But the reality is we're leveraging taking one individual and we're actually driving the wrench time improvements across the organization. And it's also a promotional opportunity for the technicians to move up and advance. And as part of what I see in other organizations too, the hiring process, what happens is we'll put a posting out and we ask the maintenance people to apply for the position, and we get no responses, and we wonder why. And the reason is because in many cases we often haven't taken in consideration overtime. So you'll see them put out a lot of times the planner is a salary position. The planner scheduler is a salary position, and the technician's an hourly position. So the HR will say, well, let's post it at this range, call it $70,000 or whatever the number is. And it happens that the technicians are actually earning more than that currently. So we can't get them to apply for it unless for some reason they want to come off night shift and go to day shift, as an example. So the reality is we have to take into consideration actually what we're paying and then compensate the people we want to apply for the job accordingly. I'll also mention too that I go into some organizations and I see where the planner's not been trained on how to plan and schedule work. And in one particular organization, they had 12 planners and they had been in the position 7 years and they never had any formal training. And so they truly never understood what the objectives were within the organization for planning and scheduling. So realize one of the very first things we have to do is when we put someone new into the position, we need to get them trained. But really training is only half of the education. The other half is actually coaching. And this is where somebody walks beside you, a mile in the moccasins approach, if you will, and looks and says, okay, what are you doing? How are you leveraging what you learned? How many job plans you developed? How have you put together the schedule? And what we find in many cases, actually, following the training, the planner goes back and the organization prevents them from planning and scheduling. So by having a coach, it enables them to actually work within the organization and bring things to the attention of management and say, okay, hey, you've got the planner doing this, but that's really not part of the role. And oh, by the way, we don't have a partnership set up with production, for example. So realize that coaching is the other half of the education. When we talk about strategic focus, realize that the planner, let's do a poll, Charles. And so as part of that, before we launch it, think about what the planner is doing. And many of you are planner schedulers. How many of you attend daily meetings? For example, like if you go to the production's last 24 hours meeting where they report, this is what occurred, this is what's happening, this is our focus for today. That's what I'm asking about in this next poll question. Go ahead, Charles, if you will.
Okay, it's launched. That's what, close to 50-50, Jeff.
About 50-50, okay. Understand, and I would have been surprised if it was any other way. So the reality is there's an old saying that the supervisor, the first line supervisor, determines the success of this week. The planner scheduler determines the success of next week and beyond. So the reality is how do we get the planner scheduler out of today, out of this week? For example, like when anytime any emergency work order comes up or any urgent work order that has to be done in the current week, that really should fall to the first level supervision to actually do a level of planning and make sure they've got the parts and break the schedule as necessary to execute that work, assuming that we're breaking the schedule for higher priority work than what's on the schedule. So thinking back to the previous boots on the ground graphics, what happens when you combine, for example, the supervisor role with the planning and scheduling role? Well, the planner scheduler, we won't be strategic next week and beyond, but we're dealing with the fires of this week. So what happens is we suck the supervisor into this week, and no planning happens if we split that role between the two. So we really need to have separate functions for planning and separate functions for supervision and different people doing those. Because if we take, again, that first level supervisor and we ask them to do the planning, what happens is planning gets thrown out the window every time an emergency comes up. So we never get ahead for next week. We only deal with this week. So the planner we talked about has to be focused on next week and beyond. How do we eliminate distractions? And so when it comes, for example, if we allow the planner to go to the daily production meeting, what happens then is they get pulled into the day, and planners are trying to do the right thing at the end of the day. What they want to do is they want to help the organization be successful. It's easy for them, in many cases, especially if they were one of the best technicians before they took the planning role, they know what has to be done. But the reality is, again, that actually hurts us for next week and beyond. And the goal of planning and scheduling is to eliminate the avoidable delays and set us up well going forward in the future. So we talked about the daily meetings. I want to talk about one other piece. And in the real estate world, we always talk about location. Believe it or not, that applies in the maintenance world as well. And it deals with the planner scheduler piece. So think about this. We talked about if sucking the planner into the daily distractions. Well, if we put the planner schedulers in where the actual workflow occurs, for example, when I was a maintenance manager and we were converting our organization from reactive to proactive, we looked at what the planner schedulers were doing, and they were actually, their office was right in the shop area. And sure, it was great to be close to the work, but what would happen is that in the back of their office area were the computers. So the maintenance guys, the technicians would come in and they'd enter their time and update the work order statuses and complete the work orders and so on at the end of the day and during the course of the day. They'd also go look up parts for the stock room, and right around the corner was the stock room window where they would start parts issued to them. But what they would do is they'd come in and they'd stop by the planner's desk and, hey, can you look up this part for me? Or, hey, did you catch any fish last week? And not that we care about, the fishing aspects, but the challenge is how do you get the planner schedulers out of that workflow? And we actually ended up taking and moving them up to a mezzanine area where they were still close to the work, but they weren't getting the constant disruptions. There were in that particular organization, there were 5 planner schedulers, and there were 100 maintenance technicians. So you can see, every time somebody passed by, they want to stop and chat. And, great to have the relationship. But at the end of the day, again, the planner scheduler has to be focused on next week. And then always this question comes up as well. Do we centralize or decentralize the planner schedulers? And whenever we're first starting out with planning and scheduling, we don't have our processes defined. We're trying to come up with templates and job plan templates, walk down templates, feedback forms, all those type things. It's really beneficial to centralize the planners. And then once you have your processes defined and the organization is educated on the role of the planner scheduler, then it makes sense for them to drift back out to the shops. I'll also mention in a decentralized role, but I'll also mention too that it's easy for the planners to be doing everything but planning and scheduling. The maintenance manager comes to you, hey, I need this. And so they're doing that. And again, if we can centralize them and focus them on things as opposed to decentralizing them, there's a big benefit to doing that as well. With regard to scheduling, realize that having a schedule sets an expectation. But realize as well that the schedule is not just about the weekend. I go into organizations and I often see where they have a weekend listing of work, and it's not actually a schedule. It just says, here's this job. We want you to do this job, this job, this job, and this job. In many cases, it doesn't even have names assigned to it. And what they've done is they've gone to the production side and say, hey, Mr. Production Manager or Mr. Operations Manager, next week or this coming weekend, we're going to do this. And oftentimes, it's really not much of a time from the time they announce the schedule to they actually get into the weekend work. Reality is we need to be thinking about how do we schedule for every hour that's available, not just, the weekend work. And then also, the schedule needs to be, we need to plan the work such, even if we do what we call a minimal job plan, which I'll talk about later, even if we do that, we still need to understand what crafts are required and how long each job will take. So that way we can actually have some level of plan to build a schedule from, rather than just a listing. I'll mention here too that everybody gets assigned work. You may have a reactive crew and a plan crew. The plan crew might be on days, for example. The reactive crew may be on the different shifts. You may have a couple people that are basically troubleshooters, but realize everybody gets assigned work. What I mean by that is the reactive crew would get assigned work, but it's lower priority work that they can break away from and come back to. So when an emergency pops up, they drop off whatever they're doing, they go deal with the emergency, they come back and they continue on working. And that way we actually, at the end of the day, get more work done. And most of the technicians actually like it that way because it keeps them busy. The night, the day, whatever passes much faster. I'll add here too, what's a realistic schedule? I mentioned that we want to schedule for 100% of the available hours. But the reality is in some organizations, when you're just starting scheduling, it may be too aggressive. And then you're putting together a schedule and the schedule can't be completed due to the level of break-ins and that type of thing. So what I suggest is utilize schedule compliance to show you how you're progressing. So for example, if you're 50% reactive, let's say, try scheduling 60% of the available hours and use schedule compliance to measure how you're doing. And we target an 85 to 90% schedule compliance ratio to tell you when it's time to move up with that. So for example, if you're getting 85 to 90% for schedule compliance and your schedule is 60%, then change it to 70%. Start scheduling 70%. When you get 85 to 90% there, start scheduling 80% and keep working it up till you're scheduling 100% of the available hours. We talked earlier about standard work, and as part of that, I have another poll question, but I want to set that up as well. When we look, for example, at the planner scheduler, what is the expectation? How much time do we want them to spend away from the desk and actually out in the field? So Charles, if you'll launch that.
Done. So we've got about 10% at 1/4, a third each for a third and a half, and then the balance of 2/3.
Okay. All right. Well, actually what we look for is we look for the planner to spend a third of the day in the field. And we want the supervisor to spend 2/3 of the day in the field. And that's the first level supervisor. So when we talked earlier about job plans, I mentioned that there's a minimal job plan and a detailed job plan. And this comes from my old friend, Doc Palmer. And with regard to the minimum, if we have 20 plans that we have to, if we have 20 jobs that we have to plan, how do we actually do that? We can't put detailed job plans together for all of them. Matter of fact, and we actually put out a survey some years ago, and we asked the question across the LinkedIn groups relative to planning and scheduling. We said, how many detailed job plans are realistic to expect the planner to come up with in the course of a week? And we came back with an average of about 2 to 3. And those are more complex jobs. Now, so if you've got 20 jobs to plan, it's important that we plan all 20 with a minimum level of planning, meaning that we need to determine the job duration, the crafts that are required, and get the materials on the way. And that's a minimal job plan. But that only works to create a detailed job plan if we have a feedback loop. And we have to have, as part of the feedback loop, a form, or we have to have education to the technicians to help them understand what we're looking for. We want to be able to get the task steps, any special equipment that we didn't mention, any parts that we missed. We're looking for that feedback to come back to us, and then the planner builds out the job plan over time. So every time we issue the job plan, it's an opportunity for us to improve the job plan. And as I mentioned, you really need some type of a template or a form for feedback. Again, you're asking those technicians specifically, how do we improve the job plan? Not necessarily what the status of the job is, but how do we actually make the plan itself better? And I'll mention that the desk is a dangerous place from which to watch the world go by. And I'll give you a perfect example. I was working with a group of planners at a university. One of the planners brought a job plan to me. Really, it was a PM task plan. And he said, Jeff, I want you to look at this. And I said, okay, great. I looked at it, and I said, well, where'd you plan this from? He said, from my desk. I said, and he went on to say, well, I was a technician. I used to do this job. I said, okay. I said, well, let's go out and walk it down. And so I got with the other planners. They wanted to join us as well. So we went over, took a little shuttle bus over to the little van, if you will, over to the vet building, and we couldn't park close by the vet building. They had a pass for parking, but the parking spaces were close by, were occupied. So we had to park further out in the parking lot. Went into the building, went upstairs, through the elevator to the very top of the roof, climbed a few stairs, got out, and what the plan was actually to transition a cooling tower from winter to summer or vice versa. And so the planner, he's following through the steps of the plan, and he's missed a few things, and he climbs up on the top, and he goes to the bottom, and he goes to the middle, and he goes to the bottom, and he goes to the top. And I'm getting tired myself climbing up and down the stairs, if you can visualize that. And I'm pointing out things. I said, well, couldn't we do everything at the top and then come to the middle and then come to the bottom? And he says, yeah, probably could. So his tasks weren't really in order. And then in addition to that, he's utilizing special tools. And I said, well, hey, you don't have those tools listed here. If we forgot those tools, obviously we've got to go all the way down to the bottom floor, walk out across the parking lot, maybe get them off the truck if we have them, come back in. And so we've got to make multiple trips doing this. And the goal is we really want to walk these jobs down to make sure we understand what's actually required. And when it comes to the standard work, we talked earlier about precision steps. You really need to be thinking about that. In just a second, I'm going to give an example of that. And I see this oftentimes in job plans. You'll see, tight torque bolts per specification. Wow, what specification? Now what happened is you sent the technician back to the shop or somewhere else to look for the specification. The reality is when you say something like that on a job plan, you need to tell them what the specification is, torque to 80 foot-pounds. Remember, the purpose of planning and scheduling is to eliminate the avoidable delays. Things like looking for information or hunting for parts or waiting on equipment to become available or starting the wrong priority work. So make it easy for people. Be sure to spell things out. And as I've talked about a good bit already, when we write job plans, whether it's PM task plans or corrective job plans, which is what I'm talking about specifically here, we really need to have good procedures that are written to a level of precision, but we still have to rely on the skills of the technician. Don't make the mistake of assuming that just having a written procedure, you can take anybody with any level of knowledge and they can execute the plan. That's not realistic. And be sure to balance that. At the same time, realize that when we talk about job plans themselves, they're training tools. So when we do have new technicians, we want to make sure they understand how to do the job correctly. So we've got to have enough detail in it. And I actually have a little story where a consultant went in behind where I was working with the site, and I was working with them on some other things, but they started to put together detailed job plans. And that consultant said, no, don't write that level, of detail. Just have the craft do what they do. And after a number of incidents that occurred, they ended up going back and adding the detail back in the job plans because the technicians, would forget things. And so I'll share with you, when we talk about reliability centered maintenance as an example, there are 6 curves that talk about how equipment fails. And the last curve is actually close to 70% of failures are self-induced. We are the enemy. And of that 70%, 40% is human error. You simply make a mistake doing something you normally do right. So it's really important that we really think about details in the job plans. And I mentioned the precision. Here's an example. Rather than check gauges or check belts, you see here, check temperature gauge on the cooling water return line, and then there may be some desired value that you seek in that. And you want to make sure they're noted. And even things like, for example, like machinery alignment, you would have a space there, and then you want them to tell you how close the tolerance was, what they did, when they finished the alignment in the X, and Y positions, for example. This is usually a challenge for all organizations, and I'll give you this example. Working with the group, and the procurement buyer, he went out and he would go out and buy least cost as opposed to best value without respect for the life cycle cost overall. So for example, he would buy this lesser quality chain, and the metal would be softer, it wouldn't hold up as well. And so he could go, but what he could do is he could go, and on his scorecard for the organization, he could go put on the scorecard, hey, I substituted this, I saved all this money. But in reality, he didn't save any money. He cost the business money, because what was happening is maintenance and operations had to go through chain changes where they changed the chain, 2 to 3 times more frequently. So you had not only the cost of the maintenance activity, the cost of the parts, but the lost time from a production standpoint as well. So it's really important that we focus on making sure that we're all headed in the same direction. And you typically have silos. In every organization, you have the maintenance silo by function, you have the production silo, you have the engineering silo, you have management, you may have procurement. And the real challenge is, how do we break those down and build partnerships? We really need to reach across the aisle and build partnerships. One of the things we did when I was a maintenance manager is we created what we call the CARROT team, Capacity Assurance and Reliability Excellence. And what that was about is it gave us an opportunity to educate our operations partners and procurement partners. At the same time, it gave them a chance to educate us. And we could look and say, okay, well, how are we actually working together toward reliability? It may surprise you, from Keith Mobley's book, the Maintenance Engineering Handbook, he talks about a study that was done by Jeff Nievenhoven some years ago. And as part of that, you find that maintenance actually owns about 17% of the overall equipment reliability. Operations and engineering owns a larger portion than maintenance does. So realize reliability is an everybody thing, not just maintenance. And we think about that systems thinking diagram that I showed you before, where we went around the work execution piece and we talked about all the different interdependencies. Reliability has a lot of interdependencies. So it's really important that we focus on how do we get everybody headed together. And realize too that from a metric standpoint, what we want to do is we want to drive behaviors. And those behaviors can cross those functional lines, with regard to operations, engineering, maintenance. So how do we actually change those and use metrics to do that? As a planner scheduler, there are a lot of supporting tools that we have. And when we look at that, for example, the CMMS is one. But in many cases, we find that the CMMS is not well implemented. Matter of fact, in some studies, you find that as much as 95% of computerized maintenance management systems don't yield the anticipated results. So if we look, for example, at like statuses, how do we march the work order through from the point of inception until we actually close it out and archive it off to history? And also the status allows us to be able to let our other partners know based on the workflows we set up. For example, as a planner scheduler, from a planning function, you may determine that parts are required, but it may not be your role to order those parts. But by having a status in the work order and having the storeroom person, who's the buyer, actually monitoring that, it might transfer over to them and they actually makes the purchase for you. Also, it may surprise you to know, may not surprise you to know, that the planner may spend as much as 5 to 6 hours a day actually trying to find parts. And this is where the bill of materials comes in. And as part of the bills of materials, it's actually really important to have the equipment hierarchy at the right level. You often see many cases where, for example, like we'll build a bill of materials based on the spare parts we check out. But if the equipment hierarchy stops at, for example, like a system level, if you take, for example, like a cartoner, on a particular cartoner, you may have 4 identical motors. And if we're only issuing those parts to the system as opposed to at the motor level, which one of those 4 motors is the one that's failing all the time? Well, you can't see that. So you have to be careful of the bills of material. Also, we need to build out the bills of material. And especially when we bring in new capital projects, we need to be thinking about how we integrate that data in. The same goes for nameplate data. And again, these are all tools that make planning and scheduling much easier overall. And then you have the partnerships with regard to storeroom processes, those supporting tools. For example, like I talked about the handshaking with regard to the status and the storeroom, for example, pulling that over. But also, what about storeroom taking a job package and building out the kit for you? And as the parts come in, they check things off the pick list. And once the parts are all there, they take and change the status from awaited materials to ready to schedule. And then we talked about the relationships between procurement. Also, there's production gatekeeper. What's a production gatekeeper, you might ask? Well, this is somebody who actually is the voice from production. And it's not necessarily, in some organizations, full-time role, some organizations not so. But what it is that key contact point that's actually going out and saying, okay, from an operations perspective, this is important to us, maintenance. And we're going to give you these assets to be able to do the work on this particular day. So these are supporting tools we have to really give consideration to be able to be more effective with regard to planning and scheduling. So in this next poll question, if we talk about wrench time is actually the time spent turning the wrenches. It doesn't include things like waiting on the equipment to be available, travel time, looking for information, starting the wrong priority work. It's all around how much time we actually spend during the course of the day physically executing the job, physically turning the wrenches. Watch that for us, if you will, Charles.
Just waiting for the results here. And Jeff, I don't know if you can see them, but I'll read them up for you. So 25% said they were less than 25%. 33 said they were in the 25 to 35 range. 25% in the 36 to 45% range, and then 8 each for the next 2 categories.
Okay, thank you. Well, it happens that what we typically see in most organizations is 25 to 35% wrench time. And reality is that we look for a world-class standard of 55 to 65% wrench time. Truth is, if you get beyond 50%, you're doing really well. So as part of this, we want to talk about how do we actually drive behaviors. And when we look at specific metrics, and I'm going to focus on a few, you don't need 20. Okay? It's really important to understand this. Metrics should change. And when we start out with metrics, we may need just a suite of 5 to 7 to get us started. Ultimately, we may build more over time. But what should happen is as the business objectives change, or as we get better, the metrics might change. And we put focus on what we measure. As old saying, what gets measured gets done. So as part of that, we want to make sure that we're focusing on the right metrics to drive the right behaviors. You really have to be careful because I'll give you this example. In one organization, the planners were measured on their accuracy with regard to estimates. And the way their approval process worked is they would have to go and estimate the job in advance and determine what the cost and the hours were, and then it would actually go through the approval process. And if they were off, once the job was done, if they were off by more than 10%, it had to go back through a reapproval process. So what happened is, even though it was the best of intentions, what happened was that the planners, to eliminate the need to go through a real approval process, they would overestimate. And when they did that with regard to hours, guess what? We didn't put enough work on the schedule. So then we didn't have people coming back to the shop earlier than they needed, and we weren't leveraging the downtime that we had available to us. So when we look at specific metrics, obviously schedule compliance is, hey, we put this on the schedule, did we do it? PM compliance, PMs, did we do what we said we're going to do? And also, this is in terms of like the 10% rule. The 10% doesn't always apply, but it kind of gives you an idea. And what it says is, for example, if we have a 30-day PM, did we do it within 3 days of when we said we were going to do it? Schedule break-in reduction. And so we should really be talking about every week in the weekly scheduling meeting these metrics from the week prior. And so what was our schedule compliance? What was our PM compliance? And what schedule breakers did we have? And the goal is we really want to reduce those over time, especially if people know about things in advance and don't tell us and they wait for it to become an emergency. That's what we're trying to get around. Also, we need to think about rework. And rework has said, okay, how many failures did we have when we didn't expect it? So in other words, we did work and within 30 days, we had a failure. We should have been able to go 90 days without having a failure. So we really need to track and understand what rework is. And of course, we want to understand, going the wrong way here. Wow. There we go. All right, and we want to be able to track reliability. I promise I was pushing the right key. So anyway, if we look from data from SMRP, what we find is that for every hour spent planning, we save 3 to 5 hours in execution and $5 to $7 in execution. So looking at wrench time studies, if you look, for example, going from 35 to 55%, that's a 57% improvement. And when we talk about wrench time, technicians get worked up about wrench time, but it's really not. What we're trying to do is see if the processes are working, not necessarily the individual. It's not about the individual. We're trying to understand are the processes working. And so what this meant in case of Jacksonville Electric Authority is you had 30 technicians, and by increasing the wrench time from 35% to 55%, it's a 57% increase. So you got basically the equivalent of 47 technicians. How many of you could use extra technicians? I'm sure pretty much everybody would raise their hand. So as part of that, we're not working the technicians harder. We're just working them more effectively because we're giving them the information they need, the tools, the parts, and giving them the time to fix it, to do the job right. So as part of that, I've also seen as low as a measured 12%. And in many of our clients, we see significant jumps, 20, 30% improvements, 40% improvements, 60% improvements. And in the case of the 12%, a 70% improvement over their maintenance practices previously. And looking across bottom line dollars with regard to case studies, we work with a number of organizations that have significantly improved it, their bottom line. One case in particular, an organization in China, it's actually a global organization, but at their site in China, basically in the first year, they returned $1.8 billion to the maintenance budget and back to the business as a whole, simply by implementing planning and scheduling effectively. So with all that said, that sums up the presentation for today.